Astronomy, the scientific study of the matter in outer space, has given people the most important aspect of life, time. Starting off, the first recorded observations of celestial object movements in 4000 BC were the Mesopotamians. The Mesopotamians were referred to as the timekeepers. Their mathematical thinking about the sun led to the discovery of time itself. The Mesopotamians were the first to discover the 60 minutes, 60 seconds, and about 360 days in a year. Because the days were slightly off the actual yearly cycle, they would have something called a leap month, where one year would have 12 months and the others would have 13. These people were relied on to track the constellations and present their seasonal findings to the agricultural community in respect to their crops. Specific constellations would appear as a new season came about. Besides keeping time, the Mesopotamians also built what was called a ziggurat for their observatories. Each level represented the 5 neighboring planets, the sun and the moon. During the same time period of the Mesopotamians were the Egyptians. The Egyptian culture was able to develop a calendar for purposes of predicting the Nile flood. They also managed to build structures such as the Great Pyramid in alignment with the cardinal points on north, east, south, and west. However, that saying, any methods behind these discoveries and structures remain unknown due to the lack of recorded evidence and plans of. Further mysteries of the earth include the Stonehenge, located in England, built in 2400 BC. The stones are arranged in a rather circular display with a gap to the northeast, whereas if a person were to stand in the center, they could clearly see the summer solstice, sun rising over a boulder off in the northeast direction. How it is possible is unknown to this day without the study of astronomy.
However, the Chinese have observation records dating back to 13th century BC, documenting their study of eclipses. Records exist for about 900 solar eclipses and 600 lunar eclipses. They use drawings to record other events in the sky, such as comets and meteor showers. Chinese astronomers have helped others better understand these special occurrences. Thales, living from 624 BC to 547 BC, having no knowledge of the eclipse cycle, managed to predict the solar eclipse, which actually ended a battle between the Lydians and the Persians in 585 BC. He was also taught from the Egyptians how to calculate the distance of a ship at sea from using 2 points on a shore, and he learned to use shadows to determine the height of pyramids. Now, our solar system cycle has evolved and become more accurate as astronomers and mathematicians have studied the outside world, but it was Pythagoras himself who introduced the idea of the planets revolving in a circular cycle. During the time period of 582 BC and 500 BC, Pythagoras and his students designed a new model to show that the Earth revolved around the central fire, which is now known as the Sun, in a 24-hour cycle, which further led to the creation of Ptolemy's solar system model. While discoveries about the solar cycle were being recorded, the Babylonians developed methods of predicting the positions of the sun, moon, and planets by 500 BC. They observed each planet's synodic period, the time it takes for a planet to return to the same position relative to the sun, to determine the patterns in time length. The observations were a result of their interest in astrology, the belief that the celestial objects influence events in Earth, such as natural disasters.
About 100 or so years after that, Aristotle, who lived from 384 BC to 322 BC, concluded that all celestial motions must be circular in order for cycles to be repeated forever. He used the theory that all falling objects go towards the center, and if the Earth were anything other than a sphere, not everywhere would objects fall straight down. He also brought up the fact that Earth's shadow is always circular when reflected from the moon during early and late stages of lunar eclipses. But Aristotle also argued that the Earth has to be motionless at the center of the universe because of the idea that all the heavy material accumulated in Earth makes it the heaviest part of the universe, therefore motionless.
Mathematician Aristarchus, during the time period of 384 BC and 322 BC, actually discovered how to calculate the relative distance to and the angular size of the moon and sun. He used an equation to set up a triangle figure to find the distance. The equation must have 2 of 3 measurements to solve, either the distance, linear diameter, or angular diameter. In order to do so, he had to determine the number of lunar diameters the moon moves while inside the Earth's shadow by comparing the length and time that the moon is completely eclipsed with how long it takes the Earth's shadow to cover the entire moon.
Eratosthenes, being another mathematician, found the size of the Earth using geometry. He sent an assistant to observe the altitude of the sun at a summer solstice in Syene, while he measured the sun's altitude in Alexandria. Once he compared the latitude of both cities, he concluded that the distance between both cities was 1/50th of the Earth's circumference. The only error in Eratosthenes' method was of an accurate distance between both cities. The measurements used back then were stadia, the time it took the messengers to travel between both cities.
Hipparchus, having little to no information about him, has his works passed down by word of mouth from other astronomers. He contributed to astronomy through refining Aristarchus' method of finding the distance to the sun and moon, a more accurate determination of the length of the year, and generally observations of the sun and moon. Sometime during early 100 BC, Hipparchus put together a systematic catalogue of the brightest stars. When compared with other star catalogues, he discovered precession, a slow movement of celestial poles with respect to the stars. Basically, the coordinates of stars shift over time. The Mayan Civilization lived about 1,000 years ago, around 1000 AD. They built buildings to align with the sunrise and sunset at the equinoxes and solstices. Mayas and Aztecs worshipped Venus. They revolved all events around Venus. They timed battles to line up with specific positions of the planet. To do so, their buildings were lined up pointing towards the northernmost and southernmost risings of Venus. They tracked positions for future predictions as well. They were also known to have made the first complex calendar. Ptolemy was the first astronomer to complete an accurate system of the planet's circular motions during 127 AD and 151 AD, which could ultimately predict positions of celestial objects. His work coincided with the ideas of previous astronomers. The model held Earth being the center of the universe, known as geocentric. The Islamic astronomers were a powerful influence on Western astronomy. Between the 7th and 15th century, they were the first to build observatories equipped with instruments to measure celestial objects. They were also able to preserve pre-existing astronomical observations by translating their works into Arabic. The Muslims compiled a catalog and managed to name and record the stars, which are still used to this day. Copernicus made the first fully developed heliocentric model of the solar system in 1473. The only problem with the cycle was that the planets orbited in perfect circles. His ideas were completely rejected, but influenced later astronomers, which changed science altogether. This rich fellow, named Brahe, was able to create tools and materials needed to make more accurate observations in 1546. He kept an abundance of detailed records, but once he failed to locate the stellar parallax, the annual apparent change in the position of a star caused by the motion of the Earth around the Sun, he concluded a new solar system model, one where the Sun and Moon orbit the Earth and the other planets orbit the Sun. This was accepted as the third alternative solar system idea. Galileo, who lived from 1564 to 1642, designed a stronger version of the spyglass, which he called the telescope. With this telescope, he observed the night sky consistently and drew sketches of the moon. During his observations, he discovered moons orbiting Jupiter and phases in the planet Venus. With these discoveries, he went against the geocentric solar system and pushed for a heliocentric solar system instead. In doing so, he questioned the system of which the church and society followed for hundreds of years. Kepler became Brahe's assistant in 1597, and once Brahe passed away, Kepler took all the research. With that, he formed the laws of planetary motion. The first law states that a planet moves on an elliptical orbit, with the sun at one focus. His second law states that planets move faster when closer to the sun. And the third law states that there is an underlying principle that governs the orbital motions of the planets, a combination of forces. His laws further helped advance astronomy and was guideline to future discoveries. Isaac Newton determined and explained the motions of objects by the year 1667. He condensed his research into 3 laws of motion. The law of inertia states that an object at rest will stay at rest unless acted upon by an outstanding force. The second law is an equation. Force equals mass times acceleration. The final law states that with every action, there is an equal and opposite reaction. With these laws, people were able to further understand movements of the Earth and the universe. Edmund Halley was the first individual to notice a recurring comet. He recorded, calculated, and argued that the comet returned every 76 years. Since 1758, the comet has been known as Halley's Comet. Albert Einstein was one of the greatest minds in the 20th century. He had 2 theories, one being the special theory of relativity and the other being general theory of relativity, which he proved both to be true. He created an equation that helps astronomers find out how much energy there is in a star, which is E equals mc squared. Einstein also resolved the paradox of photoelectric effect. He also explained space, time, and gravity. Niels Bohr was one of the scientists involved in the Manhattan Project of 1939. He created the atomic model, which was used to create the atomic bomb. He also introduced the quantum theory and quantum mechanics.
Wolfgang Pauli was around the 20th century. Wolfgang believed in what is called the spinning quantum theory. He also studied that no two electrons could exist in the same state. He also discovered that particles spin. Werner Heisenberg, alongside Niels Bohr, studied electrons at Copenhagen University. Heisenberg is most known for his uncertainty principle, which is a variety of mathematical inequalities, assuming a fundamental limit to the precisions with certain pairs of physical properties. Edwin Hubble discovered that there were more galaxies in the universe. He also believed in the theory of an expanding universe. This opened the door to George Lemaître, another person who believed in the Big Bang Theory, or an expanding universe. George Lemaître, around 1930s, was shown that all galaxies were receding from us and that Earth was. Robert Oppenheimer was the director of the Manhattan Project. He also played a role in creating the atomic bomb and Oppenheimer-Phillips process. This is the deduction or nuclear reaction. Someone who didn't believe in the Big Bang Theory was Fred Hoyle. Fred's main achievements were the study of the stars. He also helped plan and build the Anglo-Australian telescope. Kenzie and Wilson waited for their opportunity, and when they got it, they sent the Holmdel-Horn antenna and experimented with it in space and discovered a background static noise that changed in different areas of outer space. Armstrong and Aldrin were a part of the well-known Apollo 11 spacecraft, which landed on the moon in 1969, making them the first to step foot on the moon, placing the American flag there.